Hi guys, today we're starting Unit 4, our study of rational functions. So when you see a rational function, you will see two different polynomials that are being divided, because remember, ratio just means that we are dividing two different things. So it will look kind of like this example here. So the first part we're going to do is just simplifying rational expressions. So there are no equal sign in here. There's no operation, multiply, divide, addition, and subtraction other than the division that we see in the actual rational function. So our steps for this, you probably want to write this down. Remember, you can pause and rewind as needed. But step one is going to be to factor. I know how much you guys are all looking forward to doing some more factoring. And then step two, you're going to reduce using your common factors. So we're going to try to find common factors that are in the numerator, the top, and then the denominator, the bottom. A very, very important reminder is these addition and subtraction signs that are in the polynomials are gluing the separate terms of that polynomial together. So you cannot, like if I look at 1 plus 3 divided by 4 minus 3, even though these 3's are common, I can't just say that this 3 divided by this 3 reduces to 1, because that would leave me with 1 over 4. And if I actually work this problem out, I would get 1 plus 3 is 4. 4 minus 3 is 1. So the answer to this one should be 4. So make sure that you are not crossing out if there's addition and subtraction. You need matching polynomials completely. So that should make sense when we get into this. All right, so let's look at example number 1. So it says negative 2ab squared all cubed. So if I factor that, I am going to take this and write, come on, you're going to write with me, negative 2ab, and I want to do that 3 times because it's there 3 times, right? Negative 2ab all over 20a and then 4b's. So I'm going to look for any common factors that are in my numerator and denominator. So negative 2, negative 2, and negative 2. Negative 2 times negative 2 is positive 4, times another negative 2 would be negative 8. If I want to go over here and think about negative 8 divided by 20, I know that 4 goes into both of them. So negative 8 divided by 4 is actually negative 2, and 20 divided by 4 is 5. So that's going to reduce to negative 2 over 5. And now I want to come and look for some other factors. So I can take one of these a's divided one of these a's. A over a is just 1, so I do not need to worry about multiplying by 1. Those are essentially gone because they become a form of 1. And then I can take out this b with this b reduces to 1. Another b can be reduced. Any top with any bottom as long as they are exactly matching. Notice that these are joined by multiplication, so I don't have to worry about like the addition that I'll see like in number 2. All right, so now I just need to figure out what's left. So I have, let me just grab a different color. I have this a left and this a, so a times a would give me a squared. I have 2 b's here, so that's b squared, and then nothing left on my bottom. So the answer for this one would be negative 2a squared b squared all over 5. All right, let's look at the next example. So I am going to delete this. See all these tricks I've been working on to try to help you guys. Hopefully this is a little better than the last one. So first step is going to be to factor. So this one is joined by multiplication and division. So you cannot just do x squared over x squared. That breaks all rules of mathematics. So you don't want to do that. You actually have to factor so that they're joined by multiplication first. All right, so this is a normal trinomial. So I'm just thinking multiply to be negative 6 and add to be 1. So my numbers are going to be positive 3 and negative 2. And then if I look on the bottom, I want to multiply to be negative 27 and add to be negative 6. So I can do negative 9 and positive 3. All right, step 2, look for any common factors. So common factors are going to be the same exact polynomial on the top and the bottom. So these x plus 3's can cancel out, and I'd be left with x minus 2 over x minus 9. All right, That is my answer. I cannot cross out those other x's because they're glued together by that subtraction sign. So I would only be able to do those if they were the same exact. Let's look at number 3. So I want to factor first. So if I look at my numerator, I do have a GCF of 2. So I'm going to take out a 2, and that would leave me with x squared minus 4. X squared minus 4 is a difference of perfect squares, so that can be factored even more. So x plus 2 and x minus 2 becomes my difference of squares from x squared minus 4. And then this one on the bottom is your guys' favorite type. So I'm actually going to take this and work it over here because I have some space. So this is when I do bottoms up. Remember, you are totally welcome to do any method that works for you. Bottoms up's just best for me. So I multiply my A and my C. Multiply now to give me -4. Add to give me 3 would mean that I would have +4 and -3. I want to put back that 2 that I multiplied. So to undo multiplying, I'm going to divide and then reduce and move bottoms up. 4 divided by 2 would make that factor x plus 2. 1 divided by 2 does not reduce, so I'm stuck with 2 as a bottom, so that bottom moves up. So my factors of that one are going to be x plus 2 and 2x minus 1. Step 2, look for common factors. So this exactly matches that, so that goes away. And now I'm just going to write my answer. So I have 2x minus 2, you can leave it in factored form, over 2x minus 1. If you want, you can go ahead and distribute that, and then you get 2x minus 4 over 2x minus 1. Just make sure that you do not get tempted to cross out these 2 x's because they're glued together to the other parts. All right. The next part we have to do is multiplying and dividing rational expressions. So if it's dividing, it's going to be the same steps, except for the first step you're going to keep, which means you're going to leave the fraction alone, change division to multiplication, and then flip your second fraction. Then it's pretty much the same steps as simplifying. So you want to factor any expressions, then you're going to reduce using common factors, multiply across, and then we just want to double check that we did not miss any common factors. So let's look at some examples of these. So number 1 is a division. So I'm going to start by keep, change, flip. So I'm going to keep the first one, although I'm going to write it in factored form, which just means since these are monomials, I'm just expanding those exponents. I'm going to change division to multiplication. And then I'm going to flip this second one. So the 5y is going to come up top, and then 18x with 2 z's going bottom. All right, now I'm just going to look for my common factors. So 6 and 18 both can be divided by 6. 6 into 6 is 1. 18 divided by 6 gives me 3. 5 and 25 are both divisible by 5. 5 divided by 5 is 1. 25 divided by 5 is 5. And now I'm going to move to my variables. So I have an x in the top with a matching x in the bottom. It does not matter that I'm going across this because this is multiplication, not division, so they're not glued together. I just need any top with any bottom. I do not have anything else because these are all y's and they're all on the top, and these are all z's and they're all on the bottom. So now when I multiply across, I have 1y4 times 1y. So that's going to give me y to the 5th, 1, 2, 3, 4, 5 y's, over 5 times 3 would give me 15. And then I have 3 z's here and another 2 z's there, so z to the 5th. So that's my answer for that one. All right, let's look at number 2. So if you need to rewind and go back to that, you can. I'll leave that up for just a little bit longer. Okay, so I am going to first factor. If I look at this first one, there is a GCF of C. So if I take a C out, that's going to leave me C minus 3. The denominator here is a difference of squares. So the square root of C squared is C. That's my A value. The square root of 25 is 5. That's my B value. And then I just want to do plus and minus. This is multiplication, so I don't have to worry about flipping that second one or changing division to multiplication. So when I factor this top one, I want to multiply to be -5 and add to be 4. So I'm going to use +5 and -1, because those multiply to be -5 and add to be 4. And then my denominator over here, multiply to be +3, add to be -4, would be -3 and -1. All right, time to look for those common factors. So any numerator with any denominator. So this c minus 3 can be eliminated by this c minus 3 because anything over itself is 1. So that's the identity property of 1. Those are gone. Now I have c plus 5 with c plus 5. I also have c minus 1 with c minus 1. Notice I'm taking exact matches. So now I'm just going to multiply what's across. So all of these just became 1. So c times 1 is just c. And then again, all of these that are crossed out became 1. So multiplying by 1 does not do anything. And I have c minus 5. I cannot cross out those c's because this c is glued to that 5. So my answer is just c over c minus 5. Okay, I'm going to delete these. So if you want to take a picture or pause or rewind, remember you can do all of those things. All right, and now example number 3. So let me just move these over a little bit so that we can focus on example 3. All right, so there is nothing to do to factor that numerator. So 2m minus 1 is stuck. M squared minus 3m minus 10 is a polynomial with a equals 1. So we're just multiplying to be -10, adding to be -3. That would be -5 and +2. I see division. So division means I have to keep change. So I'm going to change division to multiplication and make sure I flip that. 4m plus 8 might look like it can't be factored, but remember we always want to look for a GCF, and there actually is a GCF of 4. So I want to take that GCF out and then move that bottom to now the top. 4m squared minus 1 is a difference of perfect squares. So for this one, A would be 2m and B would be 1. So remember, difference of perfect squares is A plus B and then A minus B. So there are my factors. And now I'm just going to go ahead and look for common factors, any top with any bottom. So 2m minus 1 is glued together, and that matches this 2m minus 1. I don't see anything that the 4 can be reduced to. Since this 2m is glued to that 1, I cannot do anything with those 4 and that 2. But I can do m plus 2 and m plus 2. So now I'm just going to write what's left. So I have 4 alone in my numerator, and then m minus 5 over 2m plus 1. And again, you can leave it in factored form. All right, so here are some to try. I would love for you guys to try these 3. They are challenging. I will be working on these in my office hours. Office hours on Monday are 2 to 3, and you can get to the Google Meet that's in assignments or that's in announcements. I will also be emailing you this. And I also have office hours on Tuesday from 2 to 3. So I look forward to working these out with you guys then. Have a great day. I miss you, Hawks.